We are continuing the series of chemical equilibrium. In the last lecture, we had studied about the law of mass action, in which we learned how to derive the equation for equilibrium constant, that is Kc, which comes out to be what? Concentration of products upon concentration of reactant, if you remember carefully. This is the equation that we got. And there's stoichiometric power in the obviously. So let's do some question. Let's see this question. Very, very simple question really. See, in a reaction A plus B gives C plus D. A and B are mixed in a vessel at temperature T. The initial concentration of A was twice the initial concentration of B. Okay, let us first understand how to write the chemical equations here and what the terms means. For example, at time T is equals to 0 and at time T is equals to equilibrium. Time T is equals to 0 is what? The initial time when we have not mixed the chemicals and the reaction has not been started. At that time, the question is saying the initial concentration of A was twice the initial concentration of B. It means if I consider the concentration of B as A, then the concentration of A was 2 times of A. This is the question. And what happens next? After the equilibrium is reached, the concentration of C was thrice the concentration of B. When equilibrium will be achieved, this B will be reduced by some X moles. Okay. Similarly, this also be reduced by some X moles if the reaction proceeds. And whatever moles have been reduced from the reactant side will be formed in the product side, obviously. So C will be formed X and D will be formed X. If there was 2C here, now you have to multiply this 2. But since it is only 1 C, you can't see there 1, there is a 1 C here, that's why 1X is forming. Okay. And we are subtracting X from the initial concentration. Whatever concentration is reducing from the reactant side, it is forming in the product side. You have to remember this small thing. Okay, this is how you represent the chemical reaction. Okay, and what is the question saying? After the equilibrium is reached, the concentration of C was thrice the concentration of C. It means concentration of C is 3 times of concentration of B. Calculate Kc, and they have asked the Kc. This is the all information that they have given me. At equilibrium, they are saying the concentration of C is 3 times of B. Everyone can see the concentration of C at equilibrium is what? X. It means X is equals to 3 times of B. And B is what at equilibrium? A minus X. Very good. A minus X. Can you solve this? So X is equals to 3A minus 3X. I will shift this X there. Wait a minute. Let me just shift this thing there. Okay. So where were we? We have to move this 3x there, so it will be 4x minus x. When moved to the left side, it will be add to the x. Then we'll get 4x is equals to 3a. Then x is equals to 3 upon 4 of a. We have got this. Okay. Now they have asked us the Kc. What will be the Kc? So how will you find the Kc? Kc is what? Concentration of products upon reactant. It means C, concentration of C into D upon concentration of A into concentration of B at equilibrium. Since the stoichiometric coefficient is 1 everywhere, we don't have to put anything in power. It is already 1. Okay. The concentration of C at equilibrium is what? X. And D is what? Another X. Okay. Multiply this. And concentration of A at equilibrium is what? 2A minus X. Very good. 2A minus X. Similarly, what is the concentration of B? It is also A minus X. A minus X. If I solve this, what will I get? Which show x square upon 2a minus x. Let us keep like this only. X square upon 2a minus x into a minus x. And what is the value of x? As you can see from this equation, 3 upon 4a. It means what? So 3 upon 4 whole square upon 2a minus 3 upon 4 into a minus 3 upon 4. Got it? Now you have to just solve the question and you have to find the answer. Please find the answer and answer the question in the comment section. And I will like the comments, whichever is the right answer. You have to just solve the answer. We have the value of x. We have to just put this value here and we'll get the answer. 3 upon 4 of a. Okay. Let us move to the next topic, that is Lee-Chatelier's principle. What does it say? It says that, that whenever there is an equilibrium, If equilibrium has been achieved, then, for example, a reaction is in equilibrium, whatever change we will whatever change we will try to provide in this reaction, it will try to resist the change. It will not try to how can I explain this in a better sentence? It will not allow us to disturb the equilibrium. It wants to maintain the equilibrium. Equilibrium is self-maintaining kind of thing. Okay. So there are some factors on which this principle depends, like concentration, pressure, and temperature. This is a very basic question that has been asked in NEET and JEE all the time, and we'll see what catalyst does. It does not play any role. Let me tell you. Okay, let's see how does the concentration affects the equilibrium or change in equilibrium. Suppose बच्चों, if I increase the concentration of reactant A, then what will happen? A has been increased. It means reaction will move forward to reduce the amount of A. So reaction will go where? Forward. It means what? K will increase, obviously. If the reaction is moving in forward direction, K will increase. If the reaction is moving in backward direction, K will decrease. Okay. It means what? If I increase the concentration of reactant A, if I increase the concentration of reactant, it is the concentration. I've already told, it is represented in square boxes. If I increase the concentration of reactant, then what will happen, bacha? The reaction will move in forward direction. And what does forward means? It means K value is positive or more, basically. Okay. Similarly, what will happen if I increase the concentration of products? If I increase the concentration of product, then reaction will be moving in backward direction. The reaction will move in backward direction. There is another way to say the same thing. What will happen if I reduce the concentration of A? What will happen if I reduce the concentration of A? Then you have to use your IQ, your intelligence. If the concentration of A is reducing, then what will happen? It will try to increase this concentration. It means the reaction will move again in backward direction. Okay. So you have to understand this thing, how this is a very important topic, and we will hopefully do some questions in the next video. But let us just see what are the another factors that this Lee-Chatelier principle depend upon. The next topic is or point is pressure. A simple line you have to remember that the reaction will shift to that side which has less number of moles. Very simple statement it is. If I increase the pressure, reaction will shift to the less number of mole. Nothing, no very high IQ question, nothing like that. You just have to remember this statement and you will do all the questions. Okay, for example, this is a Haber's process. Nitrogen plus hydrogen gives ammonia. Okay, what will happen if I increase the pressure? Can you calculate the moles in the reactants? 1 mole of nitrogen and 3 mole of hydrogen. It means 3 plus 1, 4 moles of gases are here, and here ammonia is only 2 moles here. So if I increase the pressure, what will happen? If I increase the pressure, I said the reaction will move to the less number of moles. Less number of moles are where the ammonia is. It means reaction will move in the forward direction. Whatever I have said, very carefully understand and remember this thing. If I increase the pressure, the reaction will move in the forward direction because it has less number of moles. I'm repeating the same statement again and again. And what will happen if the pressure is reduced? Vice versa. The reaction will move in backward direction. Okay. I hope you all understand this thing. Very small thing. Next topic, or I would say point, is temperature. How does the reaction depends on temperature? Another statement I want you to people to just remember is that for endothermic reaction, it means what? Delta H is equals to positive. We all know this thing. For endothermic reaction, if temperature is increased, reaction will move in forward direction. Okay, this simple statement you have to remember. Okay, we will do some questions also later on, but remember this point only. This point and pressure point, that where a number of mole of gases are less, reaction will move to that side. And for the temperature change, whenever we increase the temperature, if the reaction is endothermic, it means reaction will move in forward direction. Okay, you have to imagine this thing. How is this happening? We'll see later. The next point is catalyst, no effect. Just remember, catalysts do not play any role in changing the value of K or rate. Okay, you have to remember this thing. Okay, I want to give some example of temperature. For example, let's see C plus O2. Let us take some combustion reaction, give CO2. It is what? Delta H is equals to negative, because we all know it is a exothermic reaction. The heat is released. So what I had said, for example, in this reaction, if I increase the temperature, what will happen? This reaction is happening in a closed tube, and I increase the temperature. Temperature increases how? I suppose I just turn on the burner. Then what will temperature will increase? Sorry for all the hodgepodge that I have created, but I want you guys to understand this thing very clearly. What will happen if I increase the temperature? If I will increase the temperature, then what will happen? The molecules will start, colliding very heavily. Okay. So instead of forming a product, we will reduce to the effective collision will become less, and the product formed will be less. The reaction will move in the backward direction. Okay. I just want you guys to go with the statement that I had said, that if we increase the temperature in an endothermic reaction, then reaction will move in forward direction. Let us see all the three conditions are satisfied or not. This reaction is endothermic, it is negative. This reaction is exothermic. It means the initial condition is failed here. It means whatever we do, the answer will be reversed. Okay, this reaction is exothermic reaction. If I increase the temperature here, then reaction will not move in forward direction. It means what, bacho? The reaction will move in backward direction. It means carbon plus O2 will be formed more. Okay. Okay. Let us take one more example. Let us take any more example. I don't know this is exothermic or endothermic, but let's check what will happen. Suppose this reaction is endothermic. Delta H is equals to positive. Then if I ask what will happen if temperature is increased, simple answer is, and we have seen that it is an endothermic reaction. Temperature increase, it means reaction will move in forward direction. Simple. If endothermic reaction, temperature is reduced, then reaction will move in backward direction. Simple. And if the delta H is negative, and it is suppose it is an exothermic reaction, then what will happen? Completely vice versa of what we have seen earlier. That means if I increase the temperature, the reaction in backward direction, reaction will move in backward direction. If I reduce the temperature, then reaction will move in forward direction. We will do the questions in the next part, then the things will become more clearer. Whatever I have said, please read it carefully, and hopefully hope you understand all the thing. Just go with the question, and we'll see more examples in the next part. Whatever statement I have repeated now, most of the times, you have to remember for temperature and for pressure, and you will not miss a single question, whether it's JEE Advanced, Mains or NEET. Okay. Okay, thank you.